So in the last lesson, we just took a bit of time to make sure we knew how to solve trig equations. And I basically showed you that when you think of solving a trig equation like this one, sine of x equals 0.2, there's a 3-step method that you can follow to find a solution. But another important interpretation of what sine of x equals 0.2 means is it means the answer to that equation will be the same as saying, where does y equals sine x intersect with y equals 0.2? And so in some ways, when you solve a trig equation, you're solving for an intersection point between a trig graph like sine of x and 0.2 in this case. And so visually, we can see quite clearly that the answer to that would be in quadrant 1 and quadrant 2. Now, the 3-step method that we use, and which I showed in the last lesson, is we always start by finding the reference angle. And when we find the reference angle, we ignore any negatives that are involved with a particular thing. So for example, if I was doing B, and I did this in the last lesson too, I would go inverse cos, and the way we go inverse cos is we go cos of -1, and we go of 0.3. We don't go of negative 0.3, and we get some value. Then step 2 is where we deal with the negative part. We deal with the fact that cos is negative in what quadrants? It's in quadrant 2 and quadrant 3 that cos is negative, which means the answers to this original trig equation, if they are in this quadrant, they would be 180 minus the reference angle, and in this quadrant, 180 plus the reference angle. And so what I do as my 3rd step is I write down the quadrant names as Roman numerals, and then I just work out whatever the answer would be. So in this case, x would be 180 minus whatever the reference angle is, and then x would be 180 plus the reference angle. Now, if you didn't see the last lesson, that would have felt very, very quick. But I just want to make sure that you guys can do this. So let me give you 2 of these to do. I want you to solve for this trig equation, and it's not, I'm not asking for a general solution. I'm just asking for the answers in the range 0 to 360. And then I also want to do another one. I want you to solve this trig equation where tan of x equals 7, also in the domain 0 to 360. I encourage you to ask questions if you're confused, but otherwise I want you to fly solo on that one. See if you can do that following on from the last lesson. Pop the reference angle that you get in the chat. So our reference angle we've got is 64.16. Now, what are our final answers to this equation? Sine of x equals minus 0.9 going to be? My graph is telling me that they should be in quadrant. Well, the one thing is the graph tells me they should be in quadrant 3 and 4. The other thing that tells me that is that we know sine is negative in quadrant 3 and 4. And that's using something called the cost diagram. So we get the answers are going to be 244.16, and the other one is 295.84. And you can see how the algebra that we worked out with the method matches the graphical interpretation. You can only cut negative 0.9 in quadrant 3 and 4. Okay. Let me know if you have a question in the chat. I will monitor that. So that's the first one. So now see if you can do the second one, which involves tan. When does the graph of tan x equal 7? And can you solve for that algebraically? What is my reference angle going to be? Okay, Clemelo, good question. How do we know which quadrant is positive or negative? So what we use, Clemelo, to figure this out, and this goes back to an earlier trig section we did, something called the cost diagram. And so, for example, if we look at the cost diagram, cos is positive in quadrant 4, everything is positive in quadrant 1, and sine is positive here, and tan is positive here. Now, in this case, tan of x equals 7. In my second step, I need to know where tan is positive, because tan is 7 is positive. So which quadrants is tan going to be positive in? Well, it's going to be positive in quadrant 1, and it's going to be positive in quadrant 3. And this is because everything is positive in quadrant 1, and tan is positive in quadrant 3. Now, if it's in quadrant 1, it's just the reference angle as an answer. If it's in quadrant 3, it's going to be 180 plus the reference angle for my answer. Now, I still don't know what the reference angle is yet, but I do know that the answer is going to be in quadrant 1 and in quadrant 4. So I'll wait a little bit for the answers to come in. So it seems the reference angle is 81.87. And so x equals 81.87, or it equals 180 plus 81.87, which is 261.87. Now, just to make sure I'm telling you the whole truth and nothing but the truth, I want you to put I want you to type in your calculator tan of 261.87, and I want you to confirm with a thumbs up that you get very close to you get very close to 7. So the whole point of this was to find the value that when you apply tan to it, you get 7. And so if I'm telling you the truth, these values should give you the answer 7 when you apply tan to it. Okay. And then in this question, we're not focusing on general solutions, but because trig functions are periodic, because they repeat every so often, these solutions that I just found for tan will repeat every 180 degrees. And for the sine graph earlier, they will repeat every 360. And that's because the graph goes on forever, looking the same and doing a new period every 360. Okay, now that was a good little recap. I think it was important to do that. Let's move on to another exam type question. And let me just move this out the way for a second so we can move that down. So part 2 of today's working out is to apply what we learned in the last lesson to an exam question. So let's have a quick look at this. This is the graph F, and it's a sine graph that's been modified. And so I will just point out, well, it's labeled F, but just for ease of use, I'm going to color it in. So there's my yellow graph. And then the tan graph is going to be this green one here. Find out for me the value of A and the value of B, bearing in mind that you need to think, what does this change for the sine graph and what does this B change for the tan graph? Okay, over to you guys. Aha. So Paul has raised a good question, and he said, look, the normal period of the tan graph is 180. It looks like this, the period of this one is not 180. And you're right. So how can you use that to help you? In the last lesson, I told you that there was a formula where you went, whatever the old period was, or so in this case, tan old period divided by the number in front of the x, which is b, is equal to the new period. Or basically, you take the old period, divide by the number in front of the x, and what is the new period of the tan graph going to be? If you look at this graph here, what do you think's happened to it? How long does it take to do a whole tan graph? So there's half of a tan graph, and there's the other half. So how long does it take to do a full tan graph? And maybe that can help you with the B value. Because normally with a tan graph, you would fit the whole thing in 180. It looks to me like the whole period of this tan graph is actually 360. The period is double. It's almost like it's, normally the asymptote's at 90. This one's asymptote is at 180. So to find what B is, I need to move things around, and I should get that, which is a half. Oh, sorry, Paul. And Paul, what happened is in that question, I specifically said the domain 0 to 360. And so that's why we needed a second answer. So I just said arbitrarily that the domain was 0 to 360. Yeah. Okay, so B is a half. Now, what's A going to be? A over here, it looks to me like the sine graph normally goes between 1 and -1, and this one goes between 2 and -2. And so the A value should be equal to 2. It's almost like it's been stretched up by 2 in both directions. Okay, so we know A is 2, B is a half. That is question 1. Now, second question. I want you, by looking at the graph, to tell me what are the coordinates of P and Q? What are the coordinates of P and Q? Where is P and Q? I guess P is over here, and Q is over here. Now that's a good question, so I'm going to give you some time. So I don't think P is, it doesn't go quite the way up to the top. I agree that it is in line with 120, right? So you've got P, and you know its value is 120, its X value. And for Q, if this goes up in 30s, it looks to me like that would be 240. That's two. So you know that the X values for these coordinates, you got that, but now you need to figure out what these are. Now, how are you going to do that? What's special about P and Q? What's special about P and Q? There's something special about them. They look to me, yep, Gemelo and Paul, they're intersection points. And the wonderful thing about intersection points is that they are equal for both of these functions. So you could use, it's almost like you found, if you think of a simultaneous equation, you found the X value answer, and you now need to find the Y value. And so you can put this back into whichever of these two functions you like. So you've got the value Y equals the one function F, its Y equals 2 sine X. So if you want to know what goes with P, you could just go 2 times the sine of 120 and get the value over here. So what is the value that I'm going to get if I go 2 times sine 120? Hopefully it's going to be like 1.5 or something, 1.7, 1.8, somewhere. If I look at the graph, it looks like it's just below here. What value am I going to get for? Okay, so Tembacoso says 1.73. Lomero says 1.73. So I'm pretty happy that this must be 1.73. What about Q? What's Q's value going to be? What's Q's going to be answer? So we know the X value is 240. What's the Y value going to be? Okay, so let's be careful with it. I suppose we can use the same function again, because we know that there's a 2 in front. And if we put in, I just want to put in 240 this time. So 2 times the sine of 240. And we get, it seems the students of the land are saying that we get minus 1.73, which that looks very good to me, because if I look across here, it looks to me like it's approximately in line with that. Okay, now this is just to show you, you had to work out what the coordinates of these were, but one of the things that should follow from this, just to connect up the idea of intersection points, there are 2 graphs that you've got here. The one graph is Y equals 2 sine X. The other graph is Y equals tan a half X. And you have just found, I mean, just to point this out, you have found the answer to where they cut each other. You have found the intersection points of these 2 graphs. And the answer to that, and you can see this visually, are these 2 points, P and Q. So you can actually solve an equation just by looking at the intersection points, or you can solve it algebraically. But sometimes like this, graphically is a bit easier. Okay, so we've done this, we've done this. Now, next question. For which values of X, so if we look at the drawing here, the pink stuff, for which values of X is f of X less than or equal to g of X? So when we think about what that means, F was the yellow graph. So if F was the yellow graph, we're saying for which pink values is the yellow graph below the green graph, or equal to. So I want you to have a try at this, but I'll just give you that hint. So F is the yellow graph, and we want to know when is the yellow graph below the green graph, And it's saying for which values of X, and the X values that are in play are basically where it's purple. Now, there are some values that are undefined, like 180. So watch out for those, but see if you can, this is a proper, like if you want to get up to like a B or an A in mathematics, the type of question that you want to answer right. So we're going to give it some time, and I want to get some feedback from our students. Okay, so over here, the yellow looks to be above the green. So watch out. I want to know when yellow is, or when the Y value is below, so here, I think that when I start at 0, it's the wrong way around. This doesn't count. For me, I'm only interested when the yellow graph is either equal to the green graph or it's below the green graph. That's the tip I'm going to give you, so that you can think a bit more about this. Okay, so Kia's asked, how did I get A and B? So Kia, what I did for A is A deals with the amplitude of the sine graph. And normally the amplitude, okay, well, normally for a normal sine graph, it's just a 1 in front. And so it would be between 1 and -1. But because the yellow graph goes between 2 and -2, I know that the number in front must have changed to a 2. So that's the one way of doing it. The other way of doing it is to say, what is the range of this graph? It's 4 units. So what is the maximum minus the minimum divided by 2, as long as it's positive? So you could also say the highest value is 2, the lowest value is -2. And so that would give you 4 over 2, which is 2. But I don't like that way quite as much. I prefer the idea that you look at it visually and you say, normally it goes up to 1 and down to -1. And then here it goes up to 2 and down to -2. So it's been stretched vertically by a factor of 2. And so that's how I got the 2 here. Okay, I'll come back to the B in a moment. Let's look at this one. I think the first time my answer is relevant is going to be from 120. And up until I get to 180, that's going to be some of my answer for this question. So X is going to be greater than or equal to 120. And it's going to be less than 180. Now, why is it less than 180? Because 180 is an asymptote. You can't compare the green graph to the yellow one when it's undefined at that point. Now, is there anywhere else where the yellow graph is above the green graph? I think on the other side, so when X is greater than 180 and less than something. Because over here, the yellow graph is still above the green graph. So what's this point over here in line with? So I think that this is going to be 240. Because at 240, the green one goes, oh wait, no. When is the, I lie, I'm making this up. Sorry guys. I've had a moment here. I want the yellow one to be below the green graph. It's not going to, over here, it's above. I need to go over here. So this is going to be, math teachers have their moments too here. 240 is greater than or equal to X. And when is it the same again? It's going to be 360. So it's going to be like that. Apologies for that. So again, look at how the yellow graph is below the green graph over here. So that's the region I want to know about. And then it's also the yellow graph is below the green graph up to there. That is a tricky question. But I think it's important we do push ourselves as we get towards the end of this. Okay, one more, then we're going to have a break. What is the equation of the asymptote of G? What is the equation of the asymptote of G? So G refers to the green graph. What is the asymptote of the green graph? It looks to me like the asymptote is over here. And so the answer would be X is 180 degrees. Yeah. Now that's a proper exam level question with some properly difficult questions. So even if you're feeling a bit unsure, if you're following my general train of thought, it means that you're on the right track. So Impose asked, is 120 not an asymptote? It's not an asymptote. The 120 is just showing you that there is an intersection point there. They use dotted lines, which makes it a bit unsure. But in reality, you need something getting closer and closer, but never getting there. And you can see both the yellow and the green graph cross the line at 120. And so it can't be an asymptote. Okay, but good question. Havila has asked, how do I know where it is? So Havila, if you look at this, what color have I got left that I haven't used so far? It's becoming a bit like a painting here. But if you look here, you will see that the green graph, the tan graph, this gets closer and closer to the blue one, but never gets there. And so that's what makes this line an asymptote. The green, the tan graph gets closer and closer, but never crosses the blue one. And so this is an asymptote. And so it's a constant line, X is 180. Cool. Okay, we need a break because we've been working our brains hard. So everybody on your feet and let's stand up. I can feel my quads. Oh, from all the sitting. Turn your cameras
Please
on.
turn on your cameras, guys. Let's see your lovely faces.
Let's do it. Look, it's my shadow as well. With the light from the load shedding. Okay, let's take a moment. Let's just stretch up. So just stretch up your arms and then look away to the farthest point of your room or look out the window and let your eyes relax so that they're not focusing on something close to you. So focus on something far away and just give your eyes a chance to relax and stretch your body up so that you're extending your arms. And then you can drop your arms, keep your eyes focusing in the distance, but just loosen up for a second and just shake them out. Okay, shake out your legs. Shake out your legs. Okay, let's roll our shoulders. So let's do 5 rolls back. And then let's do 5 rolls forward. Okay, then let's do a tricep stretch. So we're doing this. Okay. Good for your back, and then the opposite side. Okay. Ooh. Shake it out again. Let's do this one. I'm sure what this is called, but it's good for you. Opposite arm. Okay, and then let's just do some light rotation. So arms out and just a light turn and rotate to the other side and start off very gently. You don't want any massive cracks. And then as you get looser, you can keep turning and your body should start to give you a bit more flexibility. But everyone's different, so don't overdo it. Okay, one more shake and let's do some cardio. Let's do air skipping today because we did the jumping jacks last time. And let's do 20 air skips and we'll go in 3, 2, 1. Let's go. So, let's do 5 more. 5, and then there we go. Oh, okay. So let us look at what little brain break I have prepared today. All right, we're going to the farm. What is a kitten plus a lion plus a chicken equal to? That is the question for today. What do you think the answer to that's going to be? I think this first part's not too bad. That should be 20, 20, 20. So when you get to the lion, be careful here because 2 lions minus 20. So actually 2 lions have to give you 64 because if you add 20 to both sides, basically if you add 20, that goes away and you get that. And so the lion, what's the lion going to be? I think the lion has to be half of 64, or that has to be 32. Now remember, we're trying to figure out what this is. That's the final goal. And so now we need to figure out what the chicken is doing. So 32 minus something. Okay, that must be 30. So our final thing is it's pluses. So BODMAS is not, you just add them any way we like. And 20 plus 32 is 52 plus 30 more should give us a final answer of 82. Yes, Sonic. Nompilo agrees. And I think lots of students seem to have chicken is 30. Yep, it is. Corsi 82, absolutely. Okay, cool. So yeah, I just thought we'd do something a little bit different. We can always come back to Maths 24, but it's nice to do a puzzle or two every so often.
Nicely done, everyone.
Indeed. Cool. Let us go back for a part 2 to these trig graphing questions. So let's look at another past exam paper question. Let's look at this thing. And one of the things that intimidates students a little bit with these types of questions is all this text at the top. And so what I suggest you do is just take a moment to almost introduce yourself to the characters involved in the question, right? So, what are the main characters involved here? There's a lot of descriptions about them, but who are the main players here? And in this case, the first graph is that one. It's a cos graph that has had that value looks like it would shift it up or down. And then there's a sine graph, which has this x plus p, which if we go back to the last lesson, probably has to do with a horizontal shift. And then it says we're showing you on the same system of axes. So from minus 240 to plus 240, that's just talking about the x sort of range that's involved. It goes from minus 240 to 240. It says they intersect at certain values, and that you can see on the graph. Okay, now I want you to find me the value of P and Q. So what is the value of these two unknowns? And they have to do with vertical shifting in the yellow one and horizontal shifting in the green one. And if you have a question, don't be afraid to raise your hand to ask it or ask it in the chat. And let's see how it goes. Pop your answer in the chat when you think you know what is what. I suppose we can, it says F is the yellow one. So if it helps, sometimes it's helpful to just, they all look very the same. If I'm a big fan of color coding, if you haven't noticed. It just feels like it frees my brain up a little bit. And so you can see the two graphs there. Okay, I see lots of people are going for the p-value, and I think I agree. For the p-value, I'm looking at the green graph here, and a lot of students are focusing on this thing over here. So I'll just give you that tip. What is that little red bit telling me about the green graph? What else is interesting? This is kind of interesting. If I look at the range of the yellow graph, that could tell me something as well. Well, there's actually two answers for P that could work, actually, now that I look at it. Oh, actually, no, I lie. P is a sine graph. The green one is a sine graph. So if I went the other direction, no, it wouldn't work. Yeah, it has to be. So if we look at Q, what has actually happened? So let's look at the yellow one. A cos graph normally goes between 1 and -1, right? So the green one is where the cos graph will normally be. But what's happened in this case is this cos graph, the yellow cos graph, is now between the blue things. Now, what does that mean about what happened to the graph? If you think about, like, it normally is the green, it's normally between the green layer or the green kind of marker, and now it's between the blue layer. What happened to the yellow graph? It feels like it shifted down, doesn't it? It feels like it went from the green. If you look at this green kind of little thing I drew, it looks like the whole thing moved down by a bit. How much did it move down by? And what would that make the Q value? It looks like to me it went down by a half. And the way I would describe that is Q should be -0.5. Yeah, or -0.5 is also correct. Okay, so we've done the Q. What about the P value? What I was kind of showing you with the green graph now, hey, the sine graph. Normally the sine graph would be starting over here, and it would go like that. So it's almost like I want to shift the graph. If I think of where it normally is, okay, where it normally is, I've shifted it back by 30. I've shifted it back by 30. In order to do that, this needs to be x plus 30. So to go from where it normally is to this new one, I would have to make this x plus 30. So P is going to be equal to 30. Because the whole graph has been shifted to the left by 30, which means it must be plus 30 there. Okay, now, here's another one of these interpretation questions. Determine the values of x in the given interval where f is greater than g. So which one was f? F was the yellow one, and g was the green one. And you want to look along the x-axis and see where is the yellow one above the green one, and write down an answer for me. See if you can do that. So when is yellow above green? Now, what I like to do with these questions, sometimes I color stuff in. So when is yellow above green? I feel like yellow is below green here, so I'm not interested. They're the same there, but that's not really that interesting because I want it to be above. So actually, stuff gets exciting from that point, and it's still above it, and it's still above it, and it's still above, and then they only equal each other again at the next intersection point, which was there. And what this visually helps me kind of remember is what I'm looking for. I'm looking for the values of X. But now that may not be the only answer, but let's have a look. Oh, then yellow goes below again, and it stays below until 240. And it says only in the given interval. So what's my answer going to be? How would I describe this region between here and here? There's two options. The one notation, it has like X is greater than and less than, and the other notation is where we use commas and circles. So I think that would be minus 120 on that side and 0 on this side. So between minus 120 and 0, F is above G, or using this notation, interval notation, it would go minus 120 to 0, and I'd have circular brackets like that. And both of those would be acceptable for 2 marks. Okay, give me a thumbs up if you're following our interpretation questions. Give me a thumbs down if you... So X isn't included. The endpoints aren't included, hey? And so it means that minus 120 is not included and neither is 0. It's only between, because at the endpoints, the two graphs are equal. And I want to know when it's bigger, when that one's bigger than that one. Okay. And then just to point out that in terms of intersection points, in the two graphs we dealt with here, y equals, in fact, yeah, I'm not going to worry about that. I'll come back to that another time. But basically, the intersection points are the solution to where the equations are equal to each other. And I just want to point that out again. Okay, let's go and do one more. So what we have here is another question, and there's quite a lot of detail going on, and let's just make sure we know what the main characters are. So again, we're going to get the g of x is a sine x plus p, and so it's just this little label that's wrong. So that should be a g of x. So that's a g of x. And this one over here, the cos one, is f of x. So that's a label that's wrong. Okay, so let's make sure I color code these so that you can see what's going on. So G was the yellow one. And the green one was the cos graph. And there's no values here, but that could be a 1, 2, and 3. Can you work out for me the value of A, P, B, and Q? So you're given a sine graph, which is the yellow one, and it seems to have two changes or two transformations. You have the f of x, which is a cos graph with two transformations. Work out for me the value of A, P, B, and Q. Don't worry, Tila, we will just practice these until they get boring. And like everything in life, when it's boring, then you know you've got it. A good way to maybe get oriented is ask yourself, what is changing in the yellow graph? Do you know what the A changes? I remember it changes the amplitude. So this thing over here is going to be an amplitude change. And this one over here is going to be a horizontal shift. So it's helpful to know that theory before you start, worrying about what happened. And then over here, again, this B over here is going to be amplitude. And then that Q there is going to be a period change. I've run out of space, but just to help you as you start this. So some students are saying A is 2, and I think I agree with them. Let's have a look. Yep, highest, lowest. To me, that makes sense because you can see the highest point the yellow graph gets to the lowest. That looks good to me. So A has been stretched vertically by a factor of 2. So we're good there. What about something else? What about B? Can anyone give me what B is? Feels like it's also got to do with amplitude. So where does the cos graph normally go up to, and where is this one going up to? And down to? It looks to me like B should be 3.
Mistakes.
Yeah.
Can you please have a look at Mpo's question in the chat?
I can. So Mpo is asking about working out the p-value, which is the horizontal shift. And what I want to suggest, Mpo, is it's not easy to see where this would land. And so what you might need to do is ask yourself, where does the sine graph normally go? And normally the sine graph goes from here up to there, right? It should be more curvy. But if you think about where it normally ends up being, ask yourself how far backwards has it gone? And can that help you work out what the p-value is? So it's going to the left. To me, it looks like it goes to the left by 30 degrees. So what does that force the p-value to be? So moving a graph from where it originally the sine graph would look like that, or in this case, I suppose it would go higher because of the 2. But now we want to go back, so the p-value is going to be 30, plus 30. Now that's probably the trickiest one to figure out. But another way of seeing this is normally like the sine graph would cross at 180 and it's crossing at 150. So it's gone back by 30 at that point. You can compare those 2 points too, if you like. Okay, what about Q? What's Q going to be equal to? What does Q even affect? What should I be looking at for Q? So normally the letter Q stands for the vertical shift. You're absolutely right, Tim Baker. But the problem is, look where this Q is sitting. This particular Q is sitting in front of the X, which means it's dealing with a period change for this graph. So what is the graph? It's the green one. So when we deal with period change of a graph, we normally say, what is the old period of the graph? So the old period of cos would be 360. And then we divide by the value in front of the X. And normally that would be something else, but they've chosen Q for whatever reason. So I'm going to put a Q there. Now, what is the period of this green cos graph? What is the period of this new green cos graph? How would I work it out? Where should I be looking to figure out the period of the green graph? We need some questions or comments from the students here, because this is interesting. Normally you fit a whole cos graph in 360. How much of the cos graph fits into 360 this time? Or how long would it take for us to do a whole cos graph if I went at this in this rhythm? Well, remember when I draw the cos graph, I draw it in quarters, eh? Now that to me feels like the first quarter, and that was 180 degrees. Then I draw the next quarter. So I've actually only got through half the graph, which means that the new period of the graph should actually be 720. Think about that for a moment, because the cos graph normally goes down in 90, but here it's going down in 180. Which means that the period of the graph has actually got bigger. It would take you another, if you imagine, it would take another 360 to get to the end of a full cycle of the cos graph. So what does Q then have to be? It feels like we did this trick earlier on, and we're going to move the Q across. And that to that side. And what Q value am I going to get? Yeah, we're going to get a half, or we could say 0.5. And so that was 5 marks, and it was 5, again, that's exam paper level questions. And notice how, I suppose the key things that I did was I took my time to introduce myself to the characters, the yellow and the green. And then I asked myself, what are the changes? And then I looked at each piece of the puzzle and I worked at it individually. Okay, we've run out of time for today, so we're going to call it for now. Label, could you just put the link to the quiz in the chat for the students? And then, yeah, I hope that you enjoyed today. I know we're starting to get tricky, but I think it's important in the standard class that we do start to push to that boundary between, say, like a D and a C up to the boundary between like to an A and a B. And so it's important that we include some questions like that so you can see where you're aiming. Okay. And Caitlin, how did I get 720? So I looked at how much of the cos graph fitted into 360. And normally when I draw a cos graph, I draw it by going down in 90, then like that, and like that. So normally each little quarter goes in 90s. Oh, excuse, it's getting a bit out of thing here, 360. But because the quarter is now going in, 1/4 is a jump of 180, it means, and then like half of the cos graph fits into 360, a full cycle of the cos graph must fit into 720. Does that make sense, Caitlin? Maybe let me know there.